It's my very great pleasure to be talking to Sibusiso Shezi today. He is one of the winners of the Engen My Best Lessons Award for 2008. Welcome, Sibusiso. It's great to have you here.
Thank you.
Now, what we should do is get on to the business of today's interview, which is to find out about this award that you've been given, the award that you've been awarded, and to find out a little bit more about this actual lesson that you entered as part of your presentation. Now, the award is given every year. It's been going for a few years, and it's spread around the country rather nicely. And in fact, I don't think you're the first person from KZN, but you're certainly the first person from Bulwer.
From Bulwer, I'm the first person, yeah. You're right. Yeah.
What was your lesson about?
My lesson is all about introducing the table of reduction potentials to my learners, especially in grade 11.
Now, the table of standard reduction potentials.
Yeah.
Now, there might be some people listening there to whom you are speaking absolute Greek. So let's just show a picture of the standard reduction potentials. Yeah. Okay, here's our table, and do you use table 4B or 4A?
That is what I'm using quite often every time. Yeah.
I tend to agree because I like it arranged this way around.
Yeah.
Okay. Yeah. And of course we're simply talking about things that lose or gain electrons, and these are equilibrium reactions, but the equilibrium shouldn't necessarily be shown as being in equilibrium, because we know that the equilibrium is shifted one way or the other. But there's the table that we're talking about, and it probably still means Greek to a lot of people, but at least we have our point of reference now.
Yeah.
Okay, your lesson is about introducing this table.
Yes.
What work had you done before leading up to this particular lesson, the introduction?
All right. Peter, you see, what I've done in grade 10, I've done a reactivity series of metals with my learners. Now, since they are now in grade 11, I know that they are clear about which metal is more reactive than another one.
Lithium, potassium, sodium are more reactive than calcium, and magnesium more reactive than copper, and so on.
Yeah.
And have they done that practically?
Yeah, they've done that practically. Some of them, not all of them, but since the school is a disadvantaged school, there are no equipment there that is available, so we use few of them, then we can make some conclusions with the rest of
so do you tend to do these things as demonstrations in the class?
Yeah, normally we use demonstrations because you see we're facing large groups of learners, like in grade 10 they are 78 in one classroom, so it's a very big group.
Do you have a big drop-off after grade 10?
Yeah, big drop-off. But what I've noticed is that most of the learners now are coming to school, you see. That is why maybe we've got such a large number of learners.
So maybe we're turning a corner here.
I think so.
We hope so. Okay, so you would then, they will at least have seen something of the practicalities of this thing called the reactivity series for metals.
Yes.
So they'll know that this is more reactive, this is less reactive.
Less reactive, yeah.
All right.
Yeah.
So that's a concept that you're building on. Anything else that you would refer to in leading into this lesson?
Yeah, what is important also is that these metals now, since they are representing atoms now, so what they know is that there are electrons involved there now, which means that the one that is more reactive will tend to lose electrons to the one that is less reactive. They've got that information now.
Okay, so they know that some things like to hold on to electrons, some like to give them away.
Give them off, yeah.
Okay, or they allow them to be taken, or whichever way you look at it.
Yeah.
So that's where you start. All right. This particular lesson now, what are you doing in this lesson? And by the way, is it strictly a one lesson, or is it a couple of lessons over a couple of days?
This is like a practical lesson, which is mostly one lesson.
Okay.
Yeah, when now I'm introducing this table now to my learners, because You see, what I've noticed is that they are not aware that there is plenty of information that is here.
Huge amount.
Yeah,
okay. And if
huge
they know how
amount.
to read it,
They get a lot of marks.
hardly have to learn anything because
That's
it's all
it.
there.
Yeah,
given
and
to
it's
them.
given to them free.
Sure,
Yeah.
sure. And the periodic table at
And
the
the
same
periodic
time.
table, yeah.
Anyway, so now you're going into a practical lesson
Yeah,
to introduce the table by getting them to use it.
exactly.
Okay.
Yeah.
Describe it a little further.
All right. So what I normally do now, because I'm trying to introduce this table now, but there are many things that I'm trying to do here. I'm also giving my learners a chance now to use metals that they are familiar with, because
Okay.
there are also those metals that they've never seen before. For
Okay.
example, what I normally do now, when you talk about iron, I used to take an iron nail, because that is something that they are used
Okay.
to.
Okay.
And nickel, I use a 1 rand coin.
Coins?
Yeah, for nickel.
What's the percentage of nickel in a 1 rand coin?
Uh,
It's, I
I'm
know
not
there is
too
nickel in there. But,
yeah, there is nickel, but it's not much.
It's not much, and it's
Yeah.
certainly not pure nickel.
Yeah, it's not pure.
No,
Yeah,
no,
that's what I
no.
understand. That it's not pure. Yeah, it's
Okay.
not much. In terms of percentage, I'm not too sure, but it's not much.
Okay.
Yeah. So what I normally do now, because in fact, the key point here is I want the learners now to see that when we've got a voltmeter and we connect those two metals now, a voltmeter sometimes it deflects negatively and sometimes positively.
Okay.
So what I normally do
So
now,
center zeroing voltmeter.
yes, yeah,
galvanometer,
yeah,
whatever.
because I'm trying to teach different skills here. They will come to a point where they have to record all the
Okay.
readings now in the voltmeter, because as part of my apparatus, I've got the voltmeter and a few elements that are available around me, like zinc and
zinc,
copper,
copper.
nickel, 1 rand coin, even gold. I also use gold. I used to take my ring. Yeah, that.
I bet your wife isn't pleased with
Yeah,
that.
yeah. I used to get permission from her that I'm going to use this ring now to represent gold, because
Right.
I don't know where to get gold. Now, what I normally do, I take just a simple container, a damp tissue paper with sodium chloride solution, so as to have a solution with free ions there, positive and negative.
Okay, your electrolyte. Yeah,
Yes,
yeah.
that's my electrolyte. Now I just sprinkle them or just throw them at random on top of that damp tissue paper.
Okay.
Yeah.
Right.
Yeah.
Tissue. You use tissue paper or
And-
filter paper?
Yeah,
or-
I just use a tissue
just
paper.
a plain.
Yeah.
Okay. So,
Yeah,
so
because
simple apparatus.
Simple apparatus, because I'm also teaching the teachers that it's very important to improvise now, because our schools are disadvantaged now. So you have to use all the materials that is available around you.
If I may just interject, what we're starting to see now is why you've won this award. It's because of that ability to improvise and to
improvise.
say,
Yeah.
hey, if we don't have the fancy stuff, we can
Yeah.
still show it using this. That's
Exactly.
wonderful.
Yeah, that is why also I'm using sodium chloride, because normally sodium chloride, it's plenty there. It's
Yeah.
available. Everybody knows.
Sure,
Even the learners now, when you tell them that is salt that you use to cook at home. So they know that, okay, physics is not something that is strange. It's something that is around me. Now,
But in the lab, we still don't let them taste it.
yeah,
They shouldn't.
it's not good. Yeah, it's not good. I just tell them that it may be contaminated. Yeah. What I normally do now, I just put those metals, right, I dip them in that solution in the tissue paper. And with the voltmeter now, having connected the two clips, I'm
Okay.
trying to make a very simple apparatus here. Then I allow the learners, I can demonstrate them first as a teacher, because sometimes they tend to be afraid, hey, what's going to happen here, you see. I just touch two metals, one positive,
Okay.
one negative, at random.
Right,
Yeah,
right.
anyone, just at random. But I want them to observe what is happening in the voltmeter.
Okay.
So-
So you're getting a deflection.
Yes, I just want to draw their attention to the deflection now.
Not so much the size of the deflection, but the direction of
The
the
direction first, it's very
Okay.
important, yeah.
Okay.